next presentation still with Mr. Suma on assessing Landsat Sentinel data of a shapefile of interest. So we take that quickly, and after that we will go on a 15-minute break. Thank you. Mr. Suma, over to you, please.
Thank you. Thank you very much, and I'm back again for this presentation. Download the Landsat data from the Digital Earth Africa Sandbox using a shapefile of region of interest. Most of the time, we are carrying some case study, and we download imagery. But sometimes also it is more useful if we can use the shapefile that cover our area of interest. And for that, the system will clip the shapefile and fit it on the area of interest, and we just have that area for the purpose of our work instead of downloading the whole scene. This is what this presentation will enable us to do using the notebook from the sandbox of Digital Earth Africa. One of the challenges faced in the Earth observation community, particularly in research, student conducting projects, is the lack of data. Low internet bandwidth, electricity stability, and computing resources. So many problems that we could find answer using this notebook, or find data for decision making, because you should have the exact location of your study area to carry out your analysis. Can we get raster data for a specific Digital Earth Africa product in my area of interest? Can I download those data immediately to use in a desktop application? The notebook will allow us to answer such questions by using shapefile through the different algorithms and the scripts. This tutorial will guide you through the packages to import, the connection to the data cube, the definition of the area of interest, displaying the dataset on a background map, creating a query object representing the result, rasterizing the shapefile, masking the dataset, exporting a single band GeoTIFF in a time interval, exporting a single time lapse multiband GeoTIFF, and finally exporting multiple GeoTIFF, one for each time interval of an X array. The packages to import, you have to take note of the packages below to see how they were imported with the other packages above. These packages are the packages you will need when you want to use an external dataset. You import the SYS, you import the data cube, you import the NumPy as NP, you import the Panda as PD, and you import GeoPandas as GPD from odc.geo.gel GOM, import geometry. You connect to the data cube. The data cube enables you to have access to the imagery. So you enter the following code, dc equal data cube dot data cube import dataset. You define your area of interest. Like my colleagues requested you to do, you have to create for any project a folder where you will download the zip file and extract it in your computer. You upload the shape file, and for the shape file, all these extensions, will be copied. The CPG, the DBF, the SHP, and the HX in your working folder. You define your area of interest, and for your area interest, you define here the vector path that here we use limit buku dot shape. If this one is not defined, you cannot have your area clip and download it. We create also a geopolygon and a geodata frame by defining the features, the geometry, and the coordinate reference system. And from there, we get the latitude and longitude range of the geopolygon. The lat range and the long range give you the extent in latitude and longitude. We display it on a base map. For that, we have displayed the map using the long range and the lat range. And this is our area of interest inside this red frame. We create a query object by defining the lat range, the land range, the time period here. We define the resolution of the image. We define the band, the output CRS, and the minimum geodata at 0.8. We have here the DS load underscore RRD for the product that we will be needed. The product we need here is the Landsat 8 underscore SR. The Landsat here, the LS is for Landsat 8, and the SR is surface reflectance. Then using the pixel quality parameters for USG collection 2, we find the dataset of Landsat 8 SR, and we filter it to 10 out of 38 for 80% of good quality pixel. And we apply it and we do a resampling, and then we print the result using this script. DS is equal to DS resample times 1 and 1m, and mean equal time. We have the result of our XRA dataset that give us here the different bands that we have and the other information related to the coordinate and the spatial reference. We display our results here in using the RGB function here, ds comma index equals 0. This index equals 0 here give you the first image. Recall that in computer, 0 is the beginning and followed by 1, 2, 3. So this 0 represents the first image that we have recovered. We rasterize the shapefile. For you to do a mask on an image using the shapefile, you have to convert it to a raster data. So you rasterize the shapefile so it will click on your image, and you define here the mask. X underscore rasterize geopolygon underscore GDF DS. We mask the dataset, and for that we have used the ds.where mask using the mask, and we plot the result using RGB DS index using the first image. And this is the result we obtain. We export a single band time slice GeoTIFF. We have the we will write it using the datacube.utils.cog, and the parameters and the specification are indicated on the notebook. When we export a multiple band single time slice geotiff, we define it using a for loop using the right underscore COG for I in range, in bracket, length, in bracket, ds dot time, and we close all the brackets. We define it and we write the geotiff, which give us here the image that we have. Writing, it will write it, and you will see the result on your table of content. You can apply this method to existing notebook you are working with to pursue further analysis, and it is useful for selecting specific area of interest and for transferring information between the sandbox and your GIS platform. Thank you very much. I will do a demo on the notebook where we use the Landsat. And the same will apply for the Sentinel-2. Thank you.
Okay, thank you, Mr. Suma. There is an information on the chat. Kindly join the WhatsApp group being created. This will allow document sharing and follow-up. So there is a WhatsApp group that will be created now, that is created now. Kindly join it. For the demo, Mr. Suma, do we take it immediately? Can we take it? Can we take it now?
It depends on you if we can take it now or we put it
It's
after.
better we take it now.
Okay.
Though we are behind the schedule, but let's take it because it's very important. That we need to ask some questions. We can take it now, please.
Okay. So let me share my window. Are you seeing it? Okay. So this is the notebook using downloading data from the sandbox using a shape file. I've already run it, so you can do the same when you receive the notebook and access your sandbox platform. The first operation we did here was to import the packages we will need. And you have the data cube, you have the NumPy, you have the pandas, you have the GeoPandas. Those are relevant notebooks that are necessary for processing your image. You connect to the data cube here, DC data cube, and you import data set. Definition of your area of interest. We use here, use a polygon as a geoson or S3 shapefile. We are using here an S3 shapefile, and we use the OMA Boku area. We define the lat range and the long range. When we have defined it, we have a display of the area based on the lat range and the long range on a base map. That's what we have here. This study area, you can use this minus to decrease or to increase to have a better view of your study area. You create a query object. This query is just where you have to indicate your time period and the resolution of your image, the output CRS, and the minimum of good data. Now to define, to load the data set, you define the DS, load underscore RRD, analysis ready data. That is the meaning of the RRD. That means the product, the image is ready for use. There is no processing you have to do on the product. It is an RRD product. The product now you are using is the Landsat 8 LS8 underscore SR for surface reflectors. All these other products have been deactivated. You don't need it for this purpose. And it gives here the quality parameters for the collection 2. The product here, the data set is the Landsat 8. It gives you the number of elements available and the result will be printed. We have here 4 images that will be used that are available. You have the variable data available. The red, green, blue, near infrared, shortwave infrared, and the shortwave infrared. So this information will enable you for the combination or the indices you want to study or you want to use in your application. You plot the results by indicating here the RGB using the DS, and for the index here, we use the first image 0. That one is from this time. This time indicates the number of images you have. You have 4 and it starts from 0, 1, 2, and 3. So we choose here 0. We rasterize the shapefile by creating a mask that will cover the area of study on your image. We mask the data set. That masking will enable the clipping of the image. We put ds equal ds.where mask. We display it an RGB ds using the first image, and we have the extent of our study area in color composites. We will export the band. The elements are defined, and for multiple geotiff, we represent it here. We will use the date of the satellite image to name the geotiff. We convert the current time step into an xarray.array, and we write the geotiff. And this is the image we have. We have a first image on 31st December 2018, another image on 31st January 2019, a third image on 28th February 2019, and the fourth image on 31st March 2019. That gives us the time equal 4. And the first image index equals 0 is for the image 31st December 2018. Thank you for your attention. You can go back to the kernel, clear all the outputs, we restart it, and you understand the scripts, read the comments, and execute the cell accordingly. If you miss one of the cells, you may find an error message that will indicate that something went wrong. If you are sure of what you are doing and your script is fitted to your needs, you can come to kernel and restart kernel, run all the cells. The system will process the notebook once, and you will have your results displayed.